Okay, we're going to graph a few parabolas so that you can watch and rewind and see as many times as you need to get a grasp on what we are doing here. All right, so this is number one from the day one homework. And first thing we want to notice is which variable is squared. In this case, the x is squared. That means our parabola is either open up or down. That gives us a horizontal directrix. So if we do a quick sketch, we'll have a directrix line that is horizontal somewhere. Looking at the y variable, the 8 contains our 4p. Alright, and this 8 happens to be positive, which will make our parabola open upwards. The focus inside somewhere. Okay, so now that we have a general idea of what we're going to be graphing, let's go ahead and graph it. Alright, so what's obvious here is that there is no h or k. And when there is no h or k in the equation, our vertex is at the origin. Alright, so graph the vertex, and the coordinates are 0, 0. Alright. Now a quick equation for a p-value, 4p equals 8, the number or coefficient in front of the variable that is not squared. Alright, solving for p, 8 divided by 4 will give us 2. Since p is positive, that verifies it again that the parabola will open upward. Finding p also tells us that the focus will be 2 units up from the vertex. So since the parabola opens upward, we will go up 2 units and find our focus right there. These coordinates are 0, 2. Our directrix, we just go 2 units the other direction down, and we can plot or draw our directrix line, which, since it is horizontal, it's going to be y equals a number, in this case -2. Our axis of symmetry, since the directrix is horizontal, will be a vertical line through the vertex and the focus, and it will be on the x value at x equal to 0. Lastly, how wide the parabola opens. Now we're given the equation, the absolute value of 4p will get us how wide the parabola is going to open. So substituting 2 to the p, that's the value of 4 times 2, gives us the absolute value of 8, which equals +8. Now that's the entire opening. Number 1 asks for the number of units on each side of the focus. So the focus is in between each opening or each side of the parabola. So we simply divide the 8 by 2, and we'll go 4 units to the right of the focus and 4 units to the left. We can now graph the parabola with the opening starting at the vertex. And that is our parabola for number 1. Okay, looking at number 6. Another difficult one because we have a fraction now. And we have this coefficient of 1/3 in front of our squared term, the y. So, just as before, we're going to notice which term is squared, which is the y in this case. And a quick sketch again, since the y term is squared, the parabola will have a vertical directrix. Okay? And it's going to open either to the right or the left. Now, to determine that, we need to know where our 4p is. And the 4p is usually in front of the term that is not squared. In this case, the x is by itself. So let's look at what this is going to be. We have the equation y minus k squared equals 4p plus x minus h. Okay, it's our standard equation for a parabola that opens from left to right. Now, notice the 4p is in front of the x variable, which we have another coefficient of 1. And in front of the y variable, there's nothing there. So we're going to fix that with the original equation we have. So what we're going to do is we're going to multiply both sides of the equation by 3. So that's number 6. The 3's will cancel, leaving us a y squared equal to 3x. Or we can rewrite that y squared equals 3x if you want it on the left side, like the general equation above. Alright, so we're going to use this one to graph our parabola. So if we're looking at the number 3, that tells us the parabola will open to the right this way. Alright, so again, we have y and x terms that don't have an h or k, which means there's 0, and our vertex again is at the origin. Then we'll plot it 0, 0. Okay, again, let's figure out what our p is. 4p equals 3. Okay, and we're going to divide both sides by 4, giving us p is 3/4. So the vertex, the focus is 3/4 units from the vertex. Right, and p is positive, so we have a opening to the right. So plotting 3/4, which is a little hard on this, is right about there. Focus. Alright, the directrix will be the other direction, which is between, if you're going by ones. Or to make this more visible, since we're going in quarters, let's do this. every 4 is 1 unit. Okay, so again, vertex, then 3/4 will be here. 3/4 the other way will be 3 units over. So this will make it a little easier to see. Alright, so the focus is at coordinate 0, 3/4, or 0.75 if you prefer. The directrix, the other direction, 0, negative 3/4, or 0, negative 0.75. Excuse me. Please remember that the directrix is a line. So we have a vertical line vertical line here, all the way down at 3/4. Okay, so our directrix, our axis of symmetry will be the x-axis. Alright, so our directrix is a vertical line, so that means x equals a number, in this case, negative 3/4, or x equals negative 0.75. The axis of symmetry is y equal to 0. Again, absolute value of our 4p. Our 4p equals 3, so it's really the absolute value of 3, which is a positive 3, is how wide our parabola is. And then if we have 3 or divided by 2, we get 1.5 units from the focus. So that's our focus. So this is positive 1. So 1.5 units would be here, 1 and 2. 1, 2, 3, 4. This is our negative 1. So 4 and 2 more units is another half. And we will have our parabola that opens out this way. Okay, so that's graphing the parabolas, and one where we have to get the variable in front of, get our 4p in the correct place, and deal with a fraction at the same time. Okay, and remember, you can always alter your grid here to make it more visible. You could still go by ones, but it'd be very small and a little tough to graph, but it's possible.